Like I told in an earlier video of today, 14 December 2024, I want to demonstrate again the good properties of the circuit that I published earlier on YouTube. And here it is. This is the first part and this is the second part. The first part is an Opamp oscillator and the second part is a frequency divider. I only want to refer to the earlier video, and in that video you can surely find all the links to this schematic. And I told in the earlier video that you can use it as a kind of audio oscillator, and of course when you have a certain frequency here generated inside that op-amp, you can divide that frequency with the help of that HEF chip by 2, by 2, by 2, and by 2, etc, etc. So it means that on all the pins, the output pins of that HEF chip, you will find other frequencies thus divided compared to the original frequency. And that original frequency is now generated here. I've used two capacitors, say the more or less standard capacitors when you want to do audio experiments, and they are 100 nanofarad and 10 nanofarad. So 0.1 microfarad and 0.01 microfarad. And they give, of course, different frequencies when connected to this oscillator. And now we are going to listen, because the focus is now on, say, the audio output. And like I told, you can use this divider in synthesizer circuits, etc, etc. And there are perhaps other interesting circuits on my YouTube channel. And when I have time, I will give the links. Say multivibrators working together, etc, etc. Anyway, we have now 31 kilohertz. That's very, very high. This is a waveform, and this is the divided waveform. And the most important thing is, let's listen. So here we have the oscillator, and here we have the output at the first stage of that divider chip. And now at the moment we don't hear anything at the first stage, of course, because it's divided here. 31 kilohertz is divided by 2, so we have here 15 kilohertz. That is surely not audible, and even when it's audible, there could be a problem that say YouTube, the bandwidth of YouTube cannot reproduce it. Anyway, now we go to the second pin of the divider chip. Well, perhaps you can hear it here. Waveform. Second pin, and here you can surely hear it. The third pin of that HEF chip. And the fourth pin of that HEF chip. And we go on and on. So and on and on. And here. And here perhaps. And the final divider pin etc, etc. So it surely shows that with such a simple op-amp generator you can make all kinds of output frequencies, and especially when you make this variable. I hope to show that in a better way in a following video. When you make that variable, also all these, say, divided frequencies, audio frequencies, will vary. That makes that you can make a kind of music, in a certain way. Music, of course, well, music is in general, say, a kind of complex waveform consisting of all kinds of, in general, sine waves together, etc, etc. So again, thanks for watching. Merry Christmas. Input frequency 31 kilohertz, and it's a waveform, and you have surely heard that even such a very high audio signal is, say, brought down into certain lower frequencies with the help of that 12-stage ripple counter chip. So again, thanks for watching.